Hello again. This is John Cronin from Invent Anything. For over 20 years, I've been a managing director of IP Capital Group, an intellectual property and innovation consultancy that has served over thousands of clients over 24 years, including 15% of the Fortune 500 companies. I'm an inventor of hundreds of patents, both from my work with IP Capital and previous work in technology development at IBM. If you enjoy this episode, you may also enjoy our blog where we look at current events through the lens of invention and intellectual property. In this episode, we will cover enablement, which is the next step from our previous podcast on associative thinking and continuous improvement thinking. Enablement is such a critical component of invention and patents that today's episode will cover only the basics. In time, we'll see expanding this episode to many other episodes, especially those related to case law changes, tricks, and best practices. Today we'll cover 6 topics. First of all, why is the continuous improvement thinking that we've talked about earlier, why is that not enough? The second topic is when to consider it's time to start enabling. The next topic we will talk about is what is enablement anyway, from a layman's point of view. But then in topic 4, we'll talk about enablement from the patent office's point of view, because clearly with its heads in topic 5 is the types of enablement you do to get a patent for your invention. And finally in topic 6, we'll actually review a patent so you can actually see enablement. And then, of course, we'll wrap up. But a word for our audience. For those that are really not familiar with or just getting patents, this is a great opportunity for you to learn about enablement. Another part of the audience would be for those wanting to save money, to do some of the work of your patent attorney, keeping money in your piggy bank. For those in management or supervisory levels that may want to judge to see if any idea are ready for patent process, this podcast is for you. For those who want to really understand the connection between ideas and invention and what it's all about, this is also for you. And our audience will actually see today how we will move from a concept to an idea to an enabled idea with the goal of moving towards a patent or maybe a prototype. And either way, we'll need more detail from a continuous improved idea to one that's ready to go. So let's get started. In the first topic, why is continuous improvement not enough? So one thing to understand is we need to move from an idea that worked out conceptually to one that can withstand the scrutiny of real-life implementation. What we recognize is management just doesn't invest in concepts. As they look over your shoulder and question you about your idea, you need to be able to give them some reassurance because they're going to invest your time and money in order to make this concept become a reality. Continuous improvement thinking is not enough to just understand the cost and the time. A paragraph or two of describing the idea is not enough for management to actually consider this new idea in its full depth. Many times, continuous improvement concepts won't get group buy-in unless they see more detail, further levels of problem analysis, etc. One of the things to think about is just like a seed growing into a flower, the continuous improvement idea to go to enablement is just like that flower growing from a seed. The seed or the concept needs to have higher quality and it needs to solve high-level problems. Ideas need to be planted in the right soil, so they need to have a team that believes in it. Ideas need nutrients, so that means ideas need to be developed. And ideas need sunlight, which means they need investment. So continuous improvement thinking starts the process of making things work, but the next part we will call enablement. This is the step, especially to move forward to get a patent or a publication, and many times it's enough to get management to get the technical buy-in. So let's move to topic number 2. Let's talk about enablement. When to consider it's time to start enabling from the continuous improvement process. One of the things you can readily do is recognize that management may be in support of the idea. So that's certainly a direction to take to start enabling. Many of the associative ideas that you had in the continuous improvement idea can be swept together, so more ideas can be put into the same concept. So there's more possibility that various approaches to the same direction will help enable if one of them fails. Another idea is that it's really great to have lots of ideas to choose from. As I mentioned, the quality comes from quantity. So the more ideas we can sweep together from the continuous improvement into the enablement will be better. One of the things that continuous improvement does is it leverages existing resources. So like a mining operation where people are digging the resources out of the ground to essentially move them further into some sort of value chain to make steel or to make any kind of mass-produced volume product, continuous thinking leverages these resources. So we're leveraging the resources of the organization, their ability to problem solve, the many improvement ideas they can come up with. Well, as we've talked about enablement from when it's time to get started, the next point is topic 3. What is enablement anyway, from the layman's point of view? Well, this word actually means that you need to describe things in enough detail is to show a person how something works or how to make it. Enablement doesn't necessarily mean a working model. Funny, in a short story about the Patent Office in 1836 and in 1877, the Patent Office buildings had burnt down. It turns out that prior to 1836, you actually needed to send a working model in to show your invention. But after the Patent Office burns, with most of the working models burnt away, they decided to change the requirement so that you did not need a working model. So think about that. You now have to write a document that convinces somebody that your invention works because they won't actually see the model. Enablement, in order to have it move forward, many times requires some sort of an expert or professional to help. An enablement of an invention doesn't necessarily make you the inventor, though. If you are enabling an invention as an expert for someone, if the person gives you enough direction, they're the inventor, not you. So just by having someone help you with enablement doesn't mean that you need to share who the inventor is. So don't worry about that. The other thing about what is enablement from the layman's point of view is there are many ranges of enablement, right? I mean, maybe you can get the first transistor to work, but in high volume manufacturing, the transistor might need 5 nines reliability. You certainly don't need all the cost and all the benefits and all the problems solved and to be in high volume manufacturing to be enabled. Many times, very, very manufacturing focused technologists and managers think that enablement means that it has to work in high volume production, and it doesn't. From a layman's point of view, enablement just means you need to teach how to make it and how to use it. So let's go to topic 4. What is enablement anyway from the Patent Office? Well, the Patent Office also requires that you describe how to make it and how to use the invention. As a matter of fact, you can go to Google and you can see the complete guidelines from the Patent Office of what enablement is. It's multiple pages, so get yourself a cup of coffee or tea because it'll take you some time. And I guarantee if you read through it, it'll leave you with some confusion because this is really the playfield of patent attorneys. But don't be worried. Enablement really from the Patent Office really means the same thing as I just mentioned as a layman's point of view. That you have to, as the Patent Office would consider, describe the invention in such terms that one skilled in the art can make and use the claimed invention. So what does skilled in the art actually mean? It means that if you're an engineer working on circuits and you're describing a circuit in a patent, that an engineer that has worked on circuits would understand it. You do not have to describe it to the level of detail of, let's say, a plumber to teach them electrical engineering, to teach them the circuit. So really, a person of skilled in the art, when they read your invention in enablement, needs to understand it and be able to make it. When you claim something in an invention, you have a way to kind of own it legally. And when you claim something in the claims of a patent, it needs to be enabled in the specification. The specification in the patent really needs the requisite support in the specification if you're going to claim it. So another reason for enablement, beyond describing how to make it and how to use it, is that it supports the legal basis of the claims. So good enablement does a fair job of giving you the claims. If you end up trying to get claims for things that you don't know how to make, chances are the Patent Office will not allow you to get those claims. Sometimes experimentation is needed to make the invention run. The Patent Office doesn't require experimentation needed to get a patent to show enablement, unless there's some reasonableness to it. So when you run an experiment, for instance, you might have some data that could support it. Enablement really is related to things like the breadth of the claim, the nature of the invention, the stage of the prior art, the level of ordinary skill in the art, how predictable is the art, the amount of direction provided by the inventor, having working examples, and having, if required, a fair amount of experimentation. We'll discuss this later, but those exist for composition of matter inventions. So enablement by the Patent Office has a number of factors like breadth, state of the prior art, etc., where they're going to try to make sure from the prior art and from predictability of the art that your invention is enabled. So the patent examiner gets to be the judge of whether or not your specification is enabled. Also note that the specification is the thing that provides the enabling for the filing of a patent. Let's go into topic 5, the types of enablement. And this might surprise you. There are various types of patents, then various, therefore, types of enablement. For instance, there's article of manufacturers. Those are things like toothpicks, game cards, elastic bands, and it's easy to kind of enable those with a picture and some short description. There are mechanical ideas, things like ratchets and gears and transmissions, and their enablement might have to do with drawings associated with the ratchets or the gears and transmission, where you point to each of the elements and describe what those are. You move from mechanical ideas to apparatus and machines like engines and robots, laser cannons, and all the rest. Here, enablement actually needs many more figures and many more diagrams to explain the engine parts and how it works, or the robot toys and how it works. One of the areas for enablement is software. These actually take a look at things like flow charts and flow diagrams. No code is needed for enablement for software, but if you have an app or something connected to an operating system, in a flow diagram you could show how it works. Also, user interfaces are great to show enablement. Composition of matter are types of inventions that basically are very difficult for just someone to create a composition and expect to write it up to get it enabled. Almost all composition of matter inventions are chemical formulations or new food fillings and things like that, and they do require laboratory work. So most of the time you'll see in composition of matter inventions the requisite laboratory work. Note that this is really the only area of enablement that actually requires laboratory work. There are methods of making inventions, methods of using, even methods of selling, and these particular inventions also can be enabled by flowcharts. The most sophisticated inventions are system inventions, and these combine all of the above. They may have a mechanical idea with an apparatus, with a piece of software, and the method to use it. So system inventions generally use a system diagram in the front end, and then one focuses in on the subcomponents to enable. Believe it or not, you can get patents on kits, like hair coloring kits, drill bit kits, paint roller kits, and the rest. So these inventions are more easily enabled with pictures and a short description of the elements. And finally, there are business model inventions. These are ways to make money. Suppose you come up with a new way of suggestive selling on the internet using facial recognition. Well, it turns out that this, once again, is a software invention and therefore could be enabled by a flowchart. So the types of enablement for patents are varied, and therefore the type of work you do to enable it is also varied. Let's actually take our first view of a patent, and let's pick a patent. Let's pick the one on cardboard box, the one that I had showed you before, and let's come up with a cardboard box example. Well, there were a lot to choose from. There were 65,000 patents in the United States alone on cardboard box. The patent that we're going to pick is a cardboard box that has packing materials that allow medical supplies to be shipped inexpensively without the sort of exotic phase change materials that are used today. This is a great invention for even shipping the COVID vaccine. So why don't we scroll through the patent a bit? So you'll see the link, and now we'll look at the patent. And what we're going to do is ask ourselves a question, since maybe this is the first time we're looking at a patent together. What is this thing called enablement anyway? What do we see in the patent? Well, first of all, you can see as we start to see the figures, that in figure number 1, we could see a drawing, and we could see all sorts of numbers going to the drawings, and therefore the numbers are related to the drawing. Well, that then means the following text related to the figure has to be described. But as we scroll through this invention, you can go from figure 1 to figure 2 to figure 3 to figure 4. Look at that, how we're adding more and more detail through figures. They always say 1 picture's worth 1,000 words. In patents, that's the name of the game. But notice that each of the figures have elements numbered. So let's take a look at one of those elements numbered so we can drill down on what enablement really means. Let's look at number 40. You can see here in the specification that it says optionally the third insulating material 40 substantial lines with the second barrier, as best seen in figure 3, which shows the third insulating material. The third insulating material 40 is different than the second insulating material. Again, it is believed that the difference in the materials delays the transfer of thermal energy. Boy, that's a lot of work to describe just one element. And look at all the elements of all the figures. So you can see that enablement takes some work. Wow. Certainly it's starting to give me directions on how to make this invention and to use it as you scroll through the figures. If we take a look at figure 11 as a blow-up, you'll actually see another part of enablement. They're not just talking about the box and the high-level aspects of the box. They're zooming in on the material of the walls of the cardboard box. That's an improvement. Wow. There's some more enablement. If you take a look at figure 15, you can see a chart that has temperature inside and outside the box. So obviously who made this box did some temperature measurements to show that their invention really does work. And so they're talking about temperature inside and outside the box. So there's another part of enablement. Now, if you kind of look at this, it makes sense that at the end of the day, you want to enable the temperature changes to show it, which has to do with the materials that you're going to blow up, which then has to do with all the box components of how those materials fit in. So this enablement is loaded with actual data. Figure 31 shows multiple scenarios. So this is enablement, right? It's not a concept. It's not coming from a continuous improved idea as an abstract. It's really something that teaches how to make and use it. As a management or supervisor, you literally have to believe that this can be done in order to go from a continuous improved idea to something that's really enabled. Obviously, there's probably enough instruction here on how to make this invention, but really probably not how to manufacture it, because there's lots of other things in the process to manufacture these materials. Don't let this frighten you. You have to start somewhere. Let other professionals help you with this. The finish line really here, as you get to the finish line, is to be persistent. You start off with the first figure, you start off with some of the elements, you start to describe it. You can go to the internet to help you define sort of sub-enablement pieces. You can then start putting it together and then say, man, I really have to describe how the material actually works better. So then you decide to blow it up and actually talk about the materials. And then at some point you say, I really have to convince the examiner this works. So you start to do some experiments and you start to figure out a way to show temperature. So as we approach the finish line to enablement, we can see that enablement takes a lot of work. So let's wrap up. We talked about why continuous improvement is really not enough. And we then moved it to understanding when is a good time to start considering enabling. When we start to consider that, we need to know a little bit about enablement. So we gave you kind of the layman's view of this as well as the patent office view. As a matter of fact, in topic 4, we talked about that the patent office has a whole bunch of criteria on the internet that you can look at, but it's really the playbook of the patent attorney that would understand it. We talked about the various types of enablements, from articles of manufacture to methods to business models. And we talked about which ones need sort of laboratory work, like composition of matter, where the others really don't. Boy, that's kind of neat, that there are many inventions that we can go from continuous improvement thinking to enabling it to getting a patent without ever doing a prototype. Think of that, getting patents without doing prototypes. We do a fair amount of work for companies all the time, helping them with dozens and dozens of ideas and enabling them to get patents where they've never had the prototype built. They do this because they want to do what's called forward patenting. They want to own the space before they start manufacturing, or they want to own the space to have trading cards with their competitors. We then took the dive in topic 6 to review a patent, to actually see it in detail. In these episodes, this will be the first time we've actually talked about a real patent, and we'll unravel patents even more. But at least you could see from the review of the patent the level of information required to go from that cardboard box that can ship COVID to actually getting a patent. So the next episode we're going to talk about is what is a patent, and talk about the elements underneath it, where this enablement front end will help a lot. And remember, if you found this useful, please support this podcast by linking to it and subscribing to it on YouTube. And if you're listening, we'd love to see you on Invent Anything as a blog. And if you're interested in learning more, you can read those articles in the blog about Invent Anything, and the URL is below. So thanks, and have a great day.